All right, here is the data from the screen time survey that I sent around. Um, I chose this example because I thought it had a chance to be a normal distribution, thinking about the things from the PowerPoint about normal distributions. There's a lot of different factors that can go into what determines your screen time. Um, there's a certain number of hours in a day, so there's limits on how much screen time you can use on the low end and on the high end. You can't go less than 0, you can't go more than 24. But I thought that the mean would be somewhere in the middle, enough and with enough variation so that the tails aren't going to crunch up against one of the boundaries. So I thought this has a chance to be a normal distribution. So why don't we study it and see what it looks like? So here we have the data, and what I did was took the hours and the minutes and turned it into the number of hours per day in sort of decimal form, so that I can make a histogram out of this data. There were a couple people who gave me, I think, their total hours in the week rather than the number of average hours in a day. So I just took I think there was two of those, and I took those and just divided by 7. Um, I'm assuming that is what happened. And for the purpose of our study, certainly it won't be a big deal. Anyway, so let's see, how many data points did we get? Equals count, and we'll count the number of data points here. All right, so we got 25 data points. We can calculate what the average is, or the mean, from our data set, and the standard deviation. So in Excel, it's equals STDEV for standard deviation. And then we, again, highlight the range of values. And so we get a standard deviation of 3. So a mean of about 7 with a standard deviation of about 3. I always like these to have the same number of digits, so I'll make it like that. All right. So I want to look at the histogram first to see if my assumption about a normal distribution is correct. So I've set up bins here from 1 to 12. So all of the data here is under 12 hours. And so my bins go from 1 to 12. Remember, these are the upper limits on the bins. So it goes from 0 to 1, from 1 to 2, and so on. And I'm going to make my own histogram, not use the Excel one, so I can control those bins. All right, so my input range is the hours per day, and the bin range are those bins. And I'm going to make the output, let's say right here. And let's make it plot something too, chart output. Okay. So let's see what it looks like. All right, not very normal looking. Not very normal looking. We do have a middle and a tail over here, but it's this group over here that makes this not such a normal distribution, right? We'd expect at the high end there to be lower frequency, less people at the high end, less people at the low end, and most people in the middle for a normal distribution. So this isn't totally a normal distribution. I have a theory on this, and that could be the circumstances we're in. We're in the middle of social distancing. Everybody's going to be on their phone more than usual, so I would guess that the average is going to be shifted over. But that would still make it a normal distribution. However, not everybody has the same access to different types of technology while they're home. And so some people might be relying on their phones more than they usually do, more than they would have to, which might be creating this second peak over here. And so it might actually be a bimodal distribution. Actually, that's what it looks like. So it would be something like this. All right, so not every experiment works out how you expect, but you can learn something from it. And so this tells me that this distribution might be a bimodal distribution, which is interesting. Okay, I think in general, this would be a normal distribution, so it'll be interesting if I can repeat this study next year, say in next year's class, and see if there is just one peak, and that would tell us something about the time that we're in and how people are using their devices. All right, so that's what the histogram is. It's not a normal distribution, but we can still do the analysis as if it was to see how things compare and sort of think through the mechanics of how normal distributions work. So I can look at, well, how much is within one standard deviation, how much is within two standard deviations. So we can probably do this math in our head. The mean is 6.8, the standard deviation is 3. So within one standard deviation would be from 3.8 to 9.8. Now it'll be a lot easier if I sort this column. Sort this data set. Sort by ours, smallest to largest. All right, so I'm looking for from 3.8 up to 9.8. So that would be all of this data set. What's that count? The count is 16. So 16 is 64%. So actually the normal distribution isn't too far off. Even though we have what looks like a bimodal shape, the normal distribution says 68% of the data should be within one standard deviation, and we found 64%, so not too far off. Now let's look at two standard deviations. So that would be plus or minus 6, right? So that would be 0.8 up to 12.8. Well, I don't even have to do the count here because all of the data is between 0.8 and 12.8. So in this case, the count is the total count, so it's just 25. Okay, so 100% normal distribution says it should be 95. Why is it higher? Why is this number higher? My guess is because the standard deviation is going to be bigger because we have this second group over here. We have this second group over here is kind of like an outlier. It's significantly above where the rest of the data is. And there's enough of it over here to pull the average and stretch the standard deviation. So when you go with plus or minus 2 standard deviations, you're actually talking about a wider range of the data set, and actually all of this data is within 2 standard deviations. If my theory is correct and a lot of this data should move over here under normal circumstances, the standard deviation would go down, and now 2 standard deviations might be only from here to here. Okay. Last thing on this. We can pick any value. I picked the random value 8. And then we can ask what percentage of data is above or below it. In the normal distribution activity, I said below, so in this one I'm saying above. So what percent of the data is above 8 hours per day? So above 8 hours per day would be the data from here down, right? So above 8 doesn't include 8, and that's a count of 7. And that would be 28% of the data is above an 8. What would a normal distribution say? Well, for that, we need to know what is the z-score for an 8. So let me calculate that right here. I'll put z8 as the label. The z-score is you look at the difference between the value and the mean. So 8 minus the mean. And then you divide by the standard deviation. Like that. So 0.4. This has a z-score of plus 0.4. Now I can go to the normal distribution table and look at what would be 0.4. Here we are, 0.4, 65.54. So this says the percentile of this z-score is 65.54. All right, well, what does that mean? Well, it means, let me write the number down before we forget it, 65.54 percentile. We're trying to answer how much is above it. So to get that number, we need to subtract from 100. Because if 65.54% is above, then 34.46% is below. So let me round it, 34%. All right, and so you see, even though it's not a perfect normal distribution, it's sort of bimodal, the normal distribution still does a reasonable job of explaining how the data is distributed. We have 64% within one standard deviation. Normal said it would be 68. We found 100% within two. Normal distribution says it should be 95. For this randomly chosen number of 8 hours per day, we have 28% of the data above it. Normal distribution says it should be 34. All right, so that in a nutshell is how you would use the normal distribution to analyze a data set, how you compare the normal distribution with the actual distribution, and from that point forward, you can think about what it means, right? What does it mean that something is not totally a normal distribution, or that it is totally a normal distribution? What is that information actually telling you about the context that you're studying?